Good morning, brothers and sisters. It is 11:18 a.m. Central Standard Time on January 4th, 2022. I hope the good Lord is keeping you and blessing you. Just to let you, we're going to start off with our view of the planets today. We're actually yesterday, we began our alignment with Venus and Sol, our sun. Sol. Don't we have a soul? But anyways, yesterday we had an alignment with the Earth, the Moon, and Venus, as it's in retrograde, which is why it's lit up purple. And as we're coming around the bend, so over the next few days, some of us might be feeling a little off, maybe feeling a little icky or whatever. There's a strong magnetic connection between each planet and our sun. Well, as they start to cross, the magnetic lines intertwine, and it can definitely affect the human body. And this is today, where we're more in alignment directly with Venus and the sun, and it's going to be like that for the next couple of days, probably until I would say right around the 14th. That'd be 10 days. That's interesting. And then the bands will actually start to separate. Now the bands that I'm talking about, I'm sure a lot of you have noticed from Enlil, those magnetic ties, those bands that keep us going. So yeah. And this is a look from European Space Agency at their prediction model for plasma. Oh, I actually didn't want to do that sticking thing. Oh well. And this is about where our current event is right here. Right there. This is about where we're at roughly. So as you can see now, don't get alarmed by seeing the chart way up here. They actually, as the numbers go higher, they actually compress these numbers. So they just stretch it out. I don't know if it's for visual effects or to maybe make people panic a little bit. I don't know. But we are currently looking at about 16 centimeters cubed of plasma, as you can see right here. We've got all the plasma coming at us from not just from a coronal hole, but also we did have slight filaments release in our direction. There was a few explosions, if you will, at the sun that looked to be going away, but we're always going to wind up getting a little bit of it. And here we are over at Space Weather Prediction Center, and coincidentally, today happens to be the closest that the Earth is going to be at the sun in our rotation. We happen to be closer to the sun than we will for the next 364 days. I'm starting us off here, looking at Let's Go C2 and C3, then we'll actually go over to the movies here in just a minute, because there's a couple things I wanted to show you. See right here where it's got that little overlay here? Yeah, this is the time yesterday where it actually stopped working for hours. And I mean hours. We had a total of I think it was like 13 hours that was missing yesterday, and I was waiting for it to catch up, and it didn't catch up even as of last night. And of course, this morning it did catch up. And then we can actually see those explosions there on the sun coming off the top left and the bottom right. We can see those plasma discharges supposedly going away from us. Well, looks like we're getting some of that. It's kind of interesting. And then here, as we can clearly see, one of our little friends, ooh, come here you. One of our little friends there, he's also happens to be in the very next frame. Got another one, or the same one, who knows. But either way, there we go. It's kind of amazing how we can catch those guys on radar. Oh, Borg cube right at the end. And then we'll actually be able to see the explosion come off of here, off the top and off the bottom a little bit. You can see that one there. And then it ends so that we can't really see the one coming off the bottom. You just see that little spit off there and a little bit off the bottom in there. And that's about all that we get. Here we are at Lasco C3. I've actually backdated it to the second. Slowed the speed down to 7 so we can actually get a better view of what's happening as it elapsed over the last couple of days. And the reason I do that is because, believe it or not, they actually add from some of the times that we have that are missing. Of course, you see all the Borg cubes. You can see all of our little friends. They'll kind of pop up in there. Uh-oh. Yeah, those were big. And then you can see our pops and explosions, if you will. But I don't know about you, but that doesn't look like it's going away from us. That looks like it's coming more towards us, which would make sense of why we're getting all that plasma. But anyways, from the time gaps that we have, they'll actually check out all of the data, scrub whatever they want, do some overlays, and add it back in. So a day or two later, you can go back and look at the data, and you'll see where they've removed it. And over here to Lasco C2, same thing, slowed it down to 7 so we can take a look at the slow motion. Now I will say this took a long time to really let go. You can see, I mean, this took a couple of days before it actually completely pushed off and released. Well, yeah, an entire day actually, all on the second. That's a long time. That means there was something very heavy that the sun had to really try and push off. That kind of tells you something, in my opinion. Maybe it was magnetically connected, you know, like two suns being drawn together, a negative and a positive, a north and south pole and opposites, and then once they finally got to that position to where, because our sun has polarities, all suns have polarities. There's a south pole and a north pole, and they have what's called a canceling effect, where they actually travel towards the equatorial plane, the north and the south pole magnetic field, and then when they get here, they cancel each other out. So let's say that you have a star that's coming here and it's in a similar cycle, and then all of a sudden they cancel each other out. Then you got a south, and instead of being north and south, you have a south and a north, even though the poles are the same, but the magnetic energy of it reverses. And so the polarities come down, and then it doesn't resonate with this one. So you'll have a north and south, and then you'll have a south and north, and when it cancels, and this one is still north and south, it'll actually push it off. So and it does take a little while for that event to happen. So that way could be why it was taking such a while to really push that thing off. And this is over here at Seeds from the second. Now, this might have been there the other day, but I don't remember it being this defined. And we can clearly see there's an object here and an object here. And as we advance, it will actually become more defined. So you can clearly see that there's something here. But I also remember seeing another one here, right here in this area. See how, yeah, right here. You see how the plasma kind of goes around it? So we could have more than one going on over there. More than one large body, which is, well, I would say it's surprising, but it's really not, is it? And Seeds from yesterday, as we can see, it kind of picks up. And of course, it looks like we have one here and possibly even here, as it's pushing items away from the sun. Then we see another pop off the bottom left. Not too much to report for today, though, because it is not done putting images there. And moving on today over at Seeds, we can see we go from 7:36. We actually have some time missing here to 12:12. So something happened there that they didn't want us to see. Not sure what it is. But then our next frame, we've got one of our little buddies there. We've got another one right there. So at least that's good. They didn't quite cover that up. Usually they do. Especially, well, here they actually have it covered up here. You can see there's a little gray dot right over it, right here, over this guy. And they've got one over him there. So they do try to cover it up, but they don't cover it on this, which almost seems counterproductive for trying to hide things, if you ask me. But we could be dealing with AI, which is why it does that. So, but the really interesting thing is Sechi on stereo head. So this is yesterday's. Yeah, January 3rd, stereo head Sechi. We only have one frame. Now the day previous, we had 34. Day previous to that, we had 32. So why do we only have one for yesterday? And it was right at the time of that nice little pop. Why would that be? I mean, we can clearly see that there's a nice little round object here, and we can correlate that over here on this one. Now remember, Earth is over here in this direction, okay? This satellite looks at the Earth, or at the sun from the side, so yeah, we'd be over here. Not quite. It's closer to Earth than perfectly at a 45. It's more like in this direction, but higher altitude. So, kind of hard to explain that. But and then for today, we've already got 19. So how does that work? And of course, You guys see that coming off, right? Look at that beast. That is something. And if you notice, it's nice and rounded. It's going around something. There is something here that it's going on that almost looks like it's right here. Yeah, it almost looks, yeah. It's actually going completely around it. It's right here. There's something right here, and then two little dots. So this again could be Nemesis, and then you got two little, looks like planets right here. But it's definitely engulfing something right here that they're not showing us on the other one. So we'll have to see. We'll wait till the end of the day. Now here's something that's interesting. I actually just checked this out. Look at the time here. This is today. It's 16:23. Okay, so that's 4:23 basically for Central Standard Time. All right, so or Universal Time Zone. This is 16:23, which is translates to 4:23. So this one is actually pretty far ahead, which is amazing because this one is usually behind in time. But when we come over here and we look at it from here, oh yeah, I saw that too. This only goes to 1400. It does not go past 16. What is this? Does anybody else know? Come on. Venus. Remember I showed you where the planets were? This is Venus coming into view. So no need to be alarmed, but it's actually quite nice to see him there. All of a sudden, just, you know, just from the frame before to now, all of a sudden, boop, there he is. So we'll actually be seeing him coming around and going in front of us here. It'll be working its way towards the sun, and it'll slowly disappear on Lasco C3, and then we'll see him over here on Lasco C2. It'll come around. So yeah, that's pretty cool in and of itself. But anyways, just something of note. I just thought you guys might want to see. It's pretty neat, I think. And then over here we're at spaceweatherlive.com, and we're going to take a look at our sun. High cadence. So over the last 48 hours, supposedly, but it's not. They do more like 36 hours. And of course we can see all the nice little blank outs because they don't want us to see what happened. They do that a lot. And here's the coronal hole that's going to be facing our direction. This, believe it or not, is also a coronal hole. They've just kind of shaded it in, and we can actually take a look at it from another angstrom of light, and you can see it much more prominent. But everything seems to be pretty quiet as we're going around the bin, with the exception of the backside over here. Things we're popping off. There is still some activity as it goes around the corner here, and we can actually see it acting up here. We can see how big those flares are. Those are not, or those lines are, those magnetic lines. They're very strong, and that's another thing that kind of has me curious. Anybody ever noticed that always on this right side over here, it's always dark right here? It's always dark on both of them. It's always dark right here. Why do you suppose that is? And here we are at 211 angstroms of light, and as you can clearly tell, this is the coronal hole that's coming around the corner that I was just showing you guys, and here it is here in the middle. So different angstroms of light, you can see different things on the sun, which I really actually appreciate. So this is where we're getting a lot of our plasma that we saw on the European Space Agency of Euphoria. And this is where a lot of our solar winds are coming from, and this will be giving us quite a bit here pretty soon as well. Man, these are going to wind up connecting, I think, which could give us more issues. You see the equatorial plane here? Along the entire center of the sun, it's darker. Well, that's where the north and the south polarities come and meet, that I was explaining earlier. And I figured I'd end on this one right here. This is high cadence for 195 angstroms, and we can see the polarities of the sun going around the corner. This one usually doesn't stay up to date very often, so I very, very rarely use it. I might take a peek at it once in a while, but that's about as far as I go. And every time there's a bright flash, you'll actually see it coming across the screen here. That's what those flashes were, like that one and that one. So, yeah, this is what we're looking at right now. So everybody stay safe out there and have a good one. Love is the only way forward.